This is Advanced Math, Chapter 12 on Vectors, Section F, page 2. So in the previous video, we looked at a graph, created a graph that represented the motion of a bird moving in a straight line at a constant velocity. And as we flip the page, we see basically the instructions here for what I did on the previous page. I marked the points on the graph where the line crossed the grid intersection. Um, which works because I chose my slope carefully. I numbered the intersection points beginning at 0, and I wrote the coordinate pairs for each of the points. Now, this graph over here is an example of what your graph should look like, although you will have chosen a different line. And in fact, in the example that I'm doing, I chose a different line, but I ended up with a picture that looked like this. It starts at t equals 0, t equals 1, 2, 3, and I've got the coordinates shown for each of those points. That's all we're saying. Okay, now this is the weird part. What we want to do is replot this graph as two separate lines. And the horizontal axis in our graph is going to be the time axis. The vertical axis is going to be either the x or the y. And we're going to get two different lines. So what does this mean? And just make a note of some of the things that I've said here. This is the time axis horizontally. And the vertical axis is going to be the x or y axis. So what you need to do is flipping back to the line that you graphed on the previous page. You want to come over here and looking only at the, say, the x coordinates of those points along the line. Graph each of those points here using the time value as the horizontal position and the x coordinate as the vertical position. So if I start with, say, the blue pen, I'm going to look at the x coordinates first. And the very first time value on my line on the previous page was t equals 0. So my horizontal position for my first point is going to be 0. The vertical position is going to be the x coordinate of the first point on the previous graph. And that x coordinate was -7. So that actually brings me below the bottom here. So it's going to be right about there. That's -7. So that point represents the 0 time and -7 on x. At the t equals 1 point on the previous graph, I was at x equals -4. So anything to notice is you look at the graph on the previous page that with each step in time, the x coordinate's increasing by 3. So that means I can easily graph the rest of my points just noting that as I go up in time horizontally to the right by 1 second, I'm going to increase my x coordinate by a value of 3. So this creates a series of points that go up by 3 with each step to the right. And that forms a line. I can graph that with my straight edge. And I can write an equation for that. And I'm going to write this in y equals mx plus b format, but the variables are different because now the vertical axis is the x-axis. The slope is the change in x per change in time for the x coordinate. And t is the independent variable, and b sub x is the x coordinate when time is equal to 0. It's like the y-intercept, but it's actually the x-intercept on our graph because the x-axis is vertical. It is the x value when time is equal to 0. And the x value when time is equal to 0 is -7. That is, the vertical position on this graph was -7. So our equation is going to be x equals 3, because 3 is the slope of the line I just graphed. Independent variable is time, that's the horizontal axis, -7, that's where this line crosses the vertical axis. So the form of this, again, is like a y equals mx plus b equation, except the variables are different. It's x equals 3t minus 7. But it's the same kind of idea, and it's this way of specifying this blue line that I graphed here. Okay, let's do the y coordinates as a function of time. So the first y coordinate at t equals 0 is -4. And with every step in time, our y coordinate increased by 2 units. So as I move to the right, unit by unit, I'm going to increase my vertical position by 2 units. Like that. And I can put a straight edge on that. And I can write an equation for that. Same idea. This is now going to be, it's like in y equals mx plus b format, except instead of x as the independent, it's t. It's basically the equation for this green line that I graphed here on the left. Y equals 2t minus 4. So again, 2 is the rate at which the y coordinate changes per second. This is the y coordinate of our bird when time is equal to 0. This is the rate at which x changes per second, and this is the x coordinate when time is equal to 0. What a weird concept. So the slope of the equations here represent the velocity vector. If we look at the rate of change of x, this is the rate of change of the x-coordinate and the rate of change of the y-coordinate. This is what's known as the components of a velocity vector, the moving particle. So in physics, when we talk about things moving through space with a particular speed and a specific direction, that's a quantity that is modelable as a vector. It's got a direction and a magnitude. The direction of that motion and the speed of that motion is the magnitude of it. For us, now that we know about vectors, we can write this as v, a vector, in component form where the x component is the rate of change of the x coordinate and the y coordinate, the y component, is the rate of change of the y. Rate of change meaning how much does y change per second. Okay, so in our case, that means we're going to look at the quote unquote slopes for these two lines. The x as a function of time slope was 3. So 3 goes there. You know what? I'm going to go back and change that color to blue. 3, because that was the blue equation. And then the slope for the y as a function of time was 2. So that's that. So this is the velocity vector for the bird.